What is software-defined networking, or SDN? Here is a typical network comprising of 5 switch routers. Basically, what we're going to do is take the intelligence out of the switch router and locate it in a central point. This will become the SDN controller. People refer to this process as the abstraction of the control plane and data plane, that is, separating out the control plane from the data plane within the network. In the past, we've been used to autonomous systems where each switch router makes the decision solely on the local logic on how to forward the packets. In this case, with software-defined networking, things are going to change, and we're going to go back to a more centralized model. So we start off by taking out all of the applications and putting them into the central controller. The central controller will also have its own operating system. This is where the SDN, or the software-defined networking control plane, is going to reside. The system, the controller, will interface to each one of the switches or routers within the network using an OpenFlow interface. Many of the switch routers on the market today have been adapted with this new interface. The control mechanism from each one of these switch routers up to the SDN controller should be encrypted with SSL or TLS to provide additional security within the network. Many people believe this is going to be the next step in the evolution of IP networking and will give us a lot more flexibility in the future on how new applications and protocols are deployed, launched and experimented within the IP networks of today. Basically, the SDN controller is going to interface to the switch or router using this OpenFlow interface. The SDN controller is going to configure a flow table within the remote switch router. Using standard off-the-shelf silicon or merchant silicon, we could make decisions on how to forward the packets based on their source and destination MAC addresses, their source and destination IP addresses, what action to take on specific TCP ports, and also we can maintain statistics. So, for example, one function could be to switch or route based on the MAC address. So here we can say, when you see this particular destination address, we want you to forward that traffic out onto port 1. You can also see we can keep count of the packets going through the port and feed these up to the central controller. We can also make decisions based on the IP address, but of course we can make more complex decisions using the destination address and possibly the source MAC address to make the decision on what compromises a flow. We can then make the decision on what action to take, i.e. which port to forward that flow onto. We can also have applications which act as a firewall, and we can instruct the flow table, for example, if you see TCP port 25, drop it. We can also use local logic. You may have a hybrid system where some local logic may still reside in the remote switch router. So for example, in this case, we could tell the silicon, if you see the destination address 192 with a wildcard, where W indicates a wildcard, then use the local logic to make the decision on how to forward this particular flow of traffic. And then last but not least, perhaps the most complex way of using the software-defined network is that if you can't make any match at all, then forward the packet up to the controller so that the application can interrogate it and make a decision on the best method to forward the particular packet across the network. Let's take a look at some of the basics. Within the flow table, you have MAC addresses, IP addresses, TCP ports, TCP destination ports. These addresses are typically referred to as a rule. So for example, in this particular case, if I set the address, the IP destination address of 10.10.10.1, this would constitute a rule. And when that rule is met, I have an action. And the action in this case is to forward this particular packet to port number 4. And then of course we have statistics. The statistics can be much more sophisticated, but in this case I'm just demonstrating the ability to count the number of packets being forwarded to that port. All this information can be fed up to the central controller. Since we have a central controller in the network, a lot more intelligence can be provided to the network. We have now one single point within the network which has a good overview of the network conditions. So in case of network failure, the applications at that central point can react very quickly to reroute traffic. Let's take a look at a typical application using what we would call a reactive mode. Here the packet goes into the first switch router. That packet is encapsulated, sent up to the SDN controller. The appropriate application interrogates it and makes a determination on how that packet needs to be forwarded across the network. Each flow table in turn will then be populated with the correct information to make the right routing decisions. As you can see, experimental protocols can be used. In this case, it's Allen's best path first. So if you want to experiment with new protocols, an SDN environment is ideal. It's very easy to actually set up a completely new protocol and distribute it across the network.